In this tutorial, we'll review briefly what we said in the class about test-driven developments on the simple applications of doubly linked nodes to see how we can build a chain of 3 nodes and then try to see if the code we are trying to write is really correct with respect to the expected list structure. Let's say this is the expected list structure we are aiming to build. So we have the first node being Alan, and its next will be the node storing Mark, whose next node will be the one storing Tom. And then you can see the previous reference is also pointing to the nodes accordingly. Okay, and you can see that the very first node has its previous node being null, and the last node here has its next node being null. So that's kind of the expected list structure we would like to build. Now let's just go to your Eclipse and we'll do exactly what we did in the class on Wednesday. So let's just go to Eclipse and then let's see over here we have doubly linked list projects, and then we have the implementations where we got the doubly linked nodes and doubly linked list. And now in the tests package, we're going to store all our JUnit test cases over here. Let's create a new JUnit test and click on that. Let's just call that test doubly linked list and say finish. Okay, and over here we're going to write a single test case to see if we can really build a chain of 3 nodes, and then let's see how we can write assertions to make sure that's really what we got from the code. Okay, so now let's rename this test here, and remember in JUnits, the convention is the test method should start with test. Let's say test a chain of 3 nodes. And then let's get rid of this default failed assertion here. And then we can say DLN, doubly linked node, and make sure it's imported. And DLN, let's say we have instantiated the generic parameter by using string. The first node is Tom, is a new node. And remember, you don't really necessarily have to repeat the string here. When you do the constructor on the right-hand side, you can simply leave it out. And Java compiler will be smart enough to figure that out. And you can say it stores Tom, and then the previous will be null, and the next reference will be null. And we have our second node, DLN, string of the same type, and it will be mark. And then we new DLN, and then we have mark, and also the previous will be null, but the next will be Tom. Okay, as you can just review the diagram. It's also available on the course website. We have the third node here, storing also string, and then it's called Alan, referring to a new node, and stores Alan here, and then the previous is null, and the next is mark. That's what we have. So let's now try to write some assertions to make sure we really got the expected list structure constructed. So now let's just document this. So the expected list structure is as follows. So we have Alan and followed by Mark and followed by Tom. Let's write some assertions about this. We want to say, because Alan, as we saw in the picture before, Alan is the very first nodes. So Alan's previous should be null, and Alan's next should be Mark. Similarly, Mark's previous should be Alan, and Mark's next should be Tom, and Tom's previous should be Mark, and Tom's next should be null. Okay, that's exactly the 6 assertions we're going to write out in JUnits. In some way, you can see the test cases can also be a very precise documentation of your expectation of how things should work. Let's do that. So we can say assert equals, and then we expect the previous of Alan to be null. Okay, so here we can say Alan.get previous to be null, and also we'll do another one. On the other hand, we expect Alan.get next to be Mark. Okay, so that's how we can talk about the left and right neighbors of Alan, and we do the same thing for both Mark and Tom. Let's do that quickly. Let's just do some copy and paste to save some typing. So now we'll say Mark dot get previous should be Alan, and Mark dot get next should be Tom. And now we'll do the last node. Tom dot get previous should be Mark, and Tom dot get next should be null. Okay, that's what we expect. So you can see these 6 cases are really good documentation. These test cases also serve as precise documentation of the behavior of doubly linked node operations. Okay. Right. So let's now run the JUnit test. Okay. If you go back to your package explorer over here, you can right click on this, and then you can say run as JUnit test. And we should really expect a green bar. If we don't get a green bar, that means our software is not really correct with respect to the expected list structure. If you run that, and too bad, we see there's a red bar. Okay, you can also see list JUnit tells you that somehow you are expecting something that is not null, but it was actually null. Okay, let's see where it is. If you double click on this, it tells you there's something wrong with this assertion over here. And this assertion here, we're expecting mark.getPrevious to be Alan, but somehow it's not really Alan. And as you can recall, the message from JUnits is actually null. Why don't we have a quick look? Put a breakpoint over here, and then we can run the debugger to have a slow motion view of everything. So if we click on the debugger button here, and let's now see. So now our execution stops over here. So that's where we got the errors. So now let's just have a look at, you can go either to variables over here. You will see Tom, Mark, and Alan, the 3 nodes. You can see, for example, you can see for Alan, the first node over there, the next is actually a node that stores Mark, which is expected. On the other hand, the previous of Alan is also null, as expected. That's exactly what the previous passing 2 cases actually assert you about. Let's have a look at the problematic one, which is Mark. Now let's have a look at Mark. You can see Mark storing Mark. That makes sense. The next of Mark is the node that stores Tom. Seems to be okay. However, as we can see from the diagram, we're expecting the previous of Mark to be Alan. But in this case, we actually get a previous being null. So that suggests that we didn't really set the previous reference of Mark properly. Okay, so you can see if you try to run these test cases here and also use debugger and breakpoints, that can really help you reveal the errors. Because when your software project becomes very large scale, it's difficult to really just keep track of things manually. You really need tools to help you. That's why we told you that as an engineer, you should really feel comfortable about using tools to help your software developments. Okay, so now let's see. So there should be something wrong over here because somehow these 3 lines of code did not actually build a list structure properly, especially setting up the previous references. Okay. Let me just show you another thing. If you go to expression over here, you can also type in different expressions by yourself. Let me just remove the previous ones. So remove all. So for example, you can do, for example, mark dot get previous, like that. It tells you it is null, which is not equal to Alan. Okay, that's also something you can try it out yourself. Different expressions. Okay, so now we pretty much know what the error is, so you don't necessarily have to execute everything using the debugger. Oh, you only use the debugger to the extent that you have a good idea what is wrong back in your implementation. Now we have a very good idea. We did not set the previous references properly, so now we're going to do it. Let's stop the debugger here. Let's go back to the Java perspective. So now we're going to set the previous of Mark. We got 2 choices. Either you can put Alan here, but this way it wouldn't work because at the point that you're trying to put Alan here, Alan was not even declared. So we better do it here. Okay, you can say mark.set previous to be Alan. Okay, and similarly, if you simply put a previous of Tom to be Mark, that wouldn't compile either because if you do that, at this point, mark was not even declared. Okay, so now this is not the right place to do. Okay, what we can do is we can now do Alan Tom.set previous to be mark. Okay, so these are the two missing bits from the previous implementation, and we didn't really know it unless we actually use the debugger and breakpoints. Okay, why don't we rerun the test cases? So that's test-driven developments. So you should not continue with your developments until all the test cases actually pass. Since we've got a red bar before, so that's why we didn't continue with the developments. We simply try to find out what the error is, fix our implementation, and rerun the test case to make sure we get a green bar. Okay, let's go back and then rerun the test case. And this time, let's see. We do have a green bar. That means everything up to now worked. And we always keep this single test case over there. So again, that's the concept of regression testing, which means we maintain a repository of test cases. Every time if we introduce or fix any functionality in our software, we have to make sure all the tests that we have used to pass before still pass. And any newly added tests also pass. So always green bar. Okay, you should really review the test-driven developments lecture using JUnits, as we taught before. If you've got any questions, get in touch with me. Okay, I think that's about a very short illustration that we did in the class on Wednesday, just in case you didn't catch up or you want to reproduce what I did in the class, you can follow this video. Okay, stay watching.